A circle is inscribed in a larger regular hexagon, and a smaller regular hexagon is inscribed in the circle. What is the ratio of the area of the smaller hexagon to the area of the larger hexagon? And express your answer as a common fraction. To do this question, so first what I will do is mark the center of the circle. So I will assume that this point O is the center of the circle. Now this point is also the center of the smaller hexagon and also the center of the larger hexagon. And from O, if I draw a line joining the vertices of the smaller hexagon, I divide the hexagon into 6 equilateral triangles. Why are these triangles equilateral? Simply because interior angles of a hexagon being 120 degrees, and these triangles will have angles 60 degrees. So that's 60 degrees as well. So this is an equilateral triangle. Now the thing to note here is that when I join O to the vertex of the smaller hexagon, I have actually drawn the radius of the circle. So if I were to name this as A and B, so OA and OB are the radius of the circle, and so AB being equilateral triangle AOB would also be R. So the area of triangle AOB would equal root 3 out of 4 times R square. So the area of the smaller hexagon would be 6 times root 3 out of 4 R square. That would give me 3 root 3 out of 2 R square. Now I have to find the area of the larger hexagon. So I go about it in a very similar way, but just a little bit of a difference. If that's the center, the difference is, in this case, if I were to name this now as P, O, Q, OP and OQ are no longer the radius of the circle. So what I do is I draw a line which is perpendicular to PQ, and I see that PQ is the tangent to the circle, and this line, if I say OX, is the radius, and radius is perpendicular to the tangent, so angle OXQ would be 90 degrees, and angle OQX is 60 degrees, we know that, and so angle XOQ would be 30 degrees. So angle XOQ is a right angle triangle, and I know OX is R. What I have to find is OQ. So I would find it using sine and cosine rules. So I would say cosine 30 degrees equals R divided by hypotenuse, which is OQ. So cosine 30 degrees I know is root 3 out of 2 equals R out of OQ. That would give me OQ equals 2 out of root 3R. Now this is only the side of the equilateral triangle. Okay, now to find the so this is 2 out of root 3R, 2 out of root 3R. So to find the area of this equilateral triangle, so area of triangle OPQ, I'm going to write area of triangle OPQ would be root 3 out of 4 times side square. So here this is the side, so the square of this, root 3R square. So that would give me root 3 out of 4 multiplied by 4 out of 3 r square. So I am left with that equals r square out of 3. So the area of the larger hexagon would be hexagon would be 6 times r square, not out of 3, sorry, out of root 3. It's a mistake. Don't know why I do this all the time. But what I get is r square divided by, that would be root 3. So 6 times r square divided by root 3. So that's the area of the larger hexagon. So now I have to find the ratio of the smaller hexagon divided by, not ratio, sorry, area of smaller hexagon divided by area of larger hexagon would be, the smaller is 3 root 3 out of 2 r square divided by 6 r square out of root 3, and that gives me 3 out of 2 multiplied by root 3 out of 6 r square. So the r squares get cancelled. Sorry, it's nothing. R squares get cancelled, and I am left with 3 times 2 is 6, and that gives me root 3 times root 3 is 3 out of 4, and that is the answer.